Because the longitudinal waves were coming straight through, the transverse waves had to go around. And that was one of the reasons for the delay. So they came up with names for it. So another example of a longitudinal wave is the P wave. And P stands for one of two things. I've never gotten clarification. It might actually stand for both at this point. It stands for primary wave because the longitudinal wave gets there first, or it stands for pressure wave because it's based upon one molecule smacking into another. Transverse waves, the secondary waves that come up are called S waves. And S stands for secondary because it gets there second. Or it stands for a shear wave. And shear is just a description of, if I've got something like this, shear is a shear force would be a force that would cause it to basically distort like that, as opposed to longitudinal force. So if I'm drawing out a transverse wave, well, a transverse wave physically is the position of particles going like that, so this would be a more accurate representation of a transverse wave because it would physically look like that. If you've dealt with battle ropes, those are the long ropes that are attached to a wall and then you go up and down like this for exercise and fun, I assume. Anyone done battle ropes? Got a complete one. Is fun a word I should associate with it?
No.
Yeah? All right. So for exercise and fun, this would be just sort of, you're looking at it from the side and that's what you would see. You would see these waves here. But we will still use this representation to represent longitudinal and transverse waves, just the meaning is slightly different. All right, questions to here? Kimberly.
So they're both transverse and longitudinal, like that?
This picture would be used for both.
Oh,
So if I ask you to draw a sound wave of a particular frequency or harmonic, I'm expecting you to draw something up and down like this. Scott?
For the experiment, I believe, that you were talking about, where the wave went through and then
Oh,
you had to pass.
yes.
Yeah, so which one was which again?
The one that goes through the not solid core, because transverse waves aren't going to go through fluids,
Okay.
or not very well. It's the longitudinal wave is the one that goes through.
Right, okay, thank you.
But I thought you said that they can go through they can go through solids, not liquids. Okay.
Right. Transverse waves can go through solids and not liquids. That's why it has to go around the crust, the mantle.
And the core of the earth is not solids.
And we were close to the extent of geology. I don't know. The only geology I know is the stuff I picked up in the streets.
So what's that little piece that you drew on the top? What is that for? Is that to measure or?
Well, for
No, on the thing.
that?
Yeah.
It's a seismograph. Basically, that's my drawing of a seismograph. It's the image of a barrel moving around with a needle on it. When there's an earthquake, the needle will shake.
Oh, okay. That thick part supposed to be a needle?
That's supposed to be a needle right there.
Oh, okay. All right, cool. Seismograph.
Yeah, I think now they just look like computers. All right, any other questions before we get into more vocabulary? Woo! Oh, we can feel the excitement building up. Let's do it. More vocabulary. Oh, actually, before I go on to the vocabulary, what's gonna talk about, let's hit two more words here. These are mechanical waves, just not sitting right today. These are mechanical waves because they require particles to move through it. If there are other types of waves that do not require a particle, do not require a physical object to actually move, these are electromagnetic waves. With the electromagnetic waves first theorized in physics in the 1800s, the thinking was, well, waves have to travel through something, and electromagnetic waves are coming from the sun to where we are, so there must be something in outer space. And so they theorized, sometimes it's hard to tell the difference, that in outer space there's this thing called ether. This is not the ether used by doctors to knock you out, numb you. Ether as in ethereal, sort of that substance in space. And then in the 1890s, there was an experiment that's generally credited with being the experiment which showed that ether does not exist. And it's that point where they go, oh, these don't require a medium. These are not mechanical waves. And even though the experiment was done in the 1890s, I have a textbook from 1940 which still talks about ether waves. So sometimes it takes a while. And I'm going to put in one other type of wave here called a surface wave. And the reason why I don't include it with these two right here is that the surface wave really is just a combination of the two. If I have a wave where the particles are traveling partly perpendicular and partly parallel / anti-parallel, as in on an ocean, the wave that you see flowing through on an ocean, basically the particles of water are moving somewhat circular. So it's part transverse and part longitudinal. I bring it up now just because I have seen it in some textbooks. I'm pretty sure Hewitt does not mention it, but in case you run across it, I just want you to go, oh, okay, he mentioned surface waves. It's just a combination of the other two things. All right, now then, other vocabulary. Amplitude. How big a wave is. Size of wave. If I've got my representation of a wave over here by this squiggle up and down, there's some middle point right there. The amplitude is just the distance from that middle point to the peak. Or if it is dealing with pressure, like in sound, it's from whatever the ambient pressure is in the room to whatever the peak is. Scott?
I'm not sure if you mentioned this already, the 4 stages of a wave.
The 4 what?
Stages. Did you ever mention it? I can't wait. So.
Sorry, one more time.
The 4 stages.
The 4 stages of a wave?
Mhm.
I don't think I did talk about that.
Okay. I mean, you already covered peak, but the other, sorry, it probably doesn't even matter.
I'm not quite sure what 4 stages would be.
Like, I mean, they could go, I mean, you could use them within financial planning, and then you could use them in physics too. It's the peak, and then there's like one where it's like really low.
But I generally call this the trough.
Yeah, that's
Okay, the
one
peak,
of
the
them.
trough.
And then it's like 2 more, but I can't think of right now.
Okay.
So,
If you think of the other 2, please let me know.
okay.
But along that, this is known as the peak. This is the trough. So the distance from the middle to the peak or middle to the trough is the amplitude. Or if I have trough and peak, it's half that distance. Now, the generic symbol for amplitude really is dependent upon the situation, so it's sort of case specific. But if I just wanted a generic letter to use for amplitude, I just use a capital A. Or, I just write down case specific. Because if I'm talking about an electromagnetic wave, I might use the amplitude would be a capital E for electric field, or a capital B. All right. Frequency. Actually, let's do period next. Period. The symbol for period is a capital T. For those who like to use capital T for tension, now's the time to switch. So if I have some repetitive motion happening, the period is just how long it takes to do one of whatever's being repeated. So it's the time to let's do time for one cycle of repetitive motion to occur.
Is that curve?
To occur. So if I got something oscillating up and down, the period is just how long it takes to do it once. The full cycle. So if I take a slinky and it oscillates up and down, the period is how long it takes to go from the peak back to the peak again.
Is the unit of measure for that seconds then?
It absolutely would be. So we can tack on over here that the unit of the period, the SI unit, is second. Now, seconds is officially the international standard. However, we have a couple of things that we talk about in terms of periodic motion. Earth going around the sun. What's the period of that? Not revolutions. It would be one revolution. But what do we call the period of the Earth going around the sun?
1 year.
Yes. What do we generally consider approximately the period of the Earth rotating on its axis? You can put them in terms of seconds, but not necessarily the simplest. Someone asks you how old you are, you're not being, they probably don't want it in seconds. But you could do it. All right. Frequency. The symbol I use for frequency is the same, it's the Baroque F, it's the same symbol I use for friction. And frequency in terms of this is pretty much the same thing as it is in everyday language, it's just how often something occurs. How often cycles of repetitive motion occur. In terms of units, the frequency, the unit of frequency. Give you a chance. What is a unit of frequency? Yes. Capital H, lowercase z, and that stands for hertz. It's case specific. It depends on what we're talking about. The demonstration that we'll do in the hallway, it would be centimeters or meters. If we're dealing with sound, it'd probably be pascals. Now there's a relationship between these two, period and frequency. The period is the time for one cycle of repetitive motion to occur. It's basically the number of seconds per cycle. So I could write, even though officially it's seconds, this really represents seconds per cycle. Now hertz is just basically cycles per second. So if something happens 5 times a second, its frequency is 5 hertz. The units between frequency and period are just the reciprocals of each other. And matter of fact, we can generalize it that the frequency is just 1 over the period. Or the period is 1 over the frequency. So if I'm listening to a sound that has a frequency of 400 hertz, can anybody produce this? Sometimes I have music people who can do it. This is saying basically that you have a sound like, assuming I hit 400 hertz there. The cycle is, my vocal cord is vibrating back and forth 400 times a second. It's hitting your eardrum and making your eardrum vibrate at 400 times a second. Or if we wanted to figure out how much time does it take to do it once, well, we just take the reciprocal of that. So if that's my frequency, my period is just 1 over 400, which is 0.0025 seconds. And I assume someone's about to correct me if I made a mistake.
You did.
It's right? Okay. Questions to hear before I do the next vocab word? Wavelength. So when I was doing the 400 hertz sound, think about, I have these waves that are basically coming out of my throat, more realistically like this, but we're going to represent it like this. So it's 400 hertz coming out of my throat. And the wavelength is basically how far does one of those travel within a period. Because this thing's coming out of my throat and it's traveling at the speed of sound. Wavelength is just the distance the wave travels in one period.
Is that supposed to be an X or upside down line?
That is supposed to be a lambda. One student referred to it as a drunk T. So it's distance wave travels in one period. So now, we can come up with our first formula for the speed of a wave. Now, traditionally in math class, when they talk about wavelength, they talk about the wavelength is the distance from here to here. It's the same thing as what I have over there. It's from any part, the distance from any part of a wave to its corresponding part on the next wave. So peak to peak is usually the simplest. Trough to trough also works. This point on the curve to this point on the curve. So it's any point on the curve to its corresponding point on the next cycle. All right, so speed. What is the formula for speed? Say it again.
Distance every time.
And so if I think about in one period, the time would be capital T. And the distance it goes in that is just the wavelength. So we have one formula right there for the speed of a wave is just the wavelength divided by the period. So that's wavelength over 1 times 1 over the period. I'm breaking it apart for a reason. I'm getting to a second formula. 1 over the period, what does that equal?
Zero.
The frequency.
So this becomes lambda over 1 times frequency, or just lambda times the frequency. So I have two formulas here that I could use, depending on what I'm given. I have that the speed of a wave is equal to the wavelength over the period, or frequency times the wavelength, or wavelength times frequency. It's on your mood. The order of multiplication doesn't matter. And this gets into another one of those just fun little things in physics. If you've seen the video, this will be a repeat. But I feel like this is important enough. I use the F for frequency because it just makes sense to me. But if you look at some sources in physics, they don't use F for frequency. They use the letter nu. Now the nu looks like this. And so if you look at a textbook which is using nu for frequency, it would be V is equal to nu times wavelength. They look a whole lot alike. As a matter of fact, there are some fonts that textbooks will use where the V looks more like this and the nu looks more like that.